Welcome to our last lecture on bonding. Today we are going to just briefly look into organic chemistry. We could spend a whole year, 2-3 years talking about organic chemistry, but we're only going to look at a very small slice of it to give you a kind of an introduction. We're really only going to talk about some basic naming. Often what you'll see is organic chemistry is a class that's used as a weed out class for science majors. It's a tough class, but we're going to just look at it at a very simple level, give you kind of an introduction to organic chemistry, a little peek behind the curtain, so to say. Organic chemistry is the study of carbon compounds. Why should we care about this? Well, we are carbon-based life forms. Okay, our bodies are based on carbon, so it's really an important science to study. What we see is the carbon compounds either contain carbon-carbon bonds, carbon-hydrogen bonds, or both. Okay, there'll also be some other substances that are bonded, but the backbone of these substances are carbon-carbon or carbon-hydrogen bonds. Originally, organic chemistry described the compounds as derived from living organisms. This no longer holds true because we can now synthesize these. We can make them in the laboratory. But that was originally how we described organic chemistry, as compounds made from living things. When we start looking at organic compounds, we look at what's called a structural formula. What a structural formula is simply a graphical representation or a picture of the structure of a compound showing how the atoms are arranged. For example, let's look at this. In this we have 4 carbons. Each line represents a bond. So it's a single pair they're sharing, single pair of electrons, and then carbons off. So this is the example of a structural formula, and often we will use these with organic compounds. So why so many compounds? Well, one thing, if you look at the valence electrons, carbon only has 4 valence electrons. Okay, so it has this great ability to combine with other carbon atoms and form either these long chains or rings of different sizes, and because of that it makes a lot of different compounds. Okay, and the other thing that these carbons can do is, even though they have the same, or they're made of the same number of carbons, hydrogen, they can be arranged in different shapes, and these different shapes give different properties to that molecule. We call these isomers. Isomers are compounds having the same molecular formula. Remember, molecular formula tells how many carbons, how many hydrogen, which is different from the empirical formula. Okay, but so isomers have the same molecular formula, but they have different structures or different shapes. So the same number of each element, same number of carbons, same number of hydrogen, same number of whatever is in that compound, but a different shape to the molecule. They look different, therefore they have different properties. Let's take a look at 2 examples of here. N-butane. This is a compound made up of 4 carbons and then 10 hydrogens around. Now if we rearrange that slightly, we get to what's called isobutane. You can see still the same number of carbon. There's 3, 4, 5, 6, 7, 8, 9, 10, but it has a different shape, so it has different properties. Now we're not going to get into doing this in this class. Okay, so don't worry about this, but I want you to understand what isomers are. Atoms with the same molecular formula but different shapes. What we are going to talk about in this class are hydrocarbons. These are the simplest of all organic compounds. We say they're simple because they're simply made of carbon and hydrogen. That's all it's to these. Okay. What we see here on Earth, many of these hydrocarbons exist as deposits of natural gas and petroleum, right? The basis of energy, of our cars moving, of a lot of stuff. So it's really important. What we see, natural gas, petroleum, are basically formed when things die. They can become decompressed and they decompose. Okay, and they form over millions and millions of years, and we call them fossil fuels. Well, the problem is now we're using these fossil fuels up quicker than they can be replaced, so they're limited resources. So that's why right now there's all this emphasis on finding alternative fuels and more fuel efficiency, because we're running out of our limited supply of hydrocarbons. So hydrocarbons, guys, there's three groups that we're going to talk about: the alkanes, the cycloalkanes, and the alkenes. Alkanes are hydrocarbons, okay, but they're made of carbon atoms bonded by a single covalent bond. So they're only sharing one pair of electrons in it. Okay, they're what we call a saturated, meaning it contains the maximum number of hydrogen as possible. So the generic formula of a hydrocarbon is CnH2n plus 2. What this means is, let's say it's C1. Okay, that would mean that hydrogen would be 2 times 1 is 2 plus 2, 4. So it'd be C1H4, or CH4, which is methane. Okay. Another example could be ethane. Here it is. We got 2 carbons, so that would mean hydrogen is 2 times 2 is 4, plus 2 is 6. So 1, 2, 3, 4, 5, 6 carbons. Okay. All alkanes are going to end in A-N-E, and that lets us know that they have single covalent bonds. Here is the structural formula of ethane as well. I'll give you a picture of it there. Now, something cool that these alkanes can do is they can form into a circle or a sphere kind of thing. And we call these cycloalkanes. They're carbon atoms connected by a single covalent bond, so we're still in the single bond, but they form a ring structure or a circle structure. Okay, they are a type of alkanes because they have the single covalent bonds. They are saturated still. Okay, and here is their generic formula, CnH2n. Notice, unlike the alkanes, there's not the plus 2. The reason is that they form a ring. Okay, so we lose 2 of the hydrogens when they do that. Example, cyclopropane. Here we got 3 carbons, 1, 2, 3. They're in a ring here, and then since we have 3 carbons, it should be 6 hydrogens. 1, 2, 3, 4, 5, and 6. And there's a picture of it as well. So both alkanes and cycloalkanes have single bonds. Okay. The final group we're going to talk about are alkenes. In alkenes, what we see is that 2 carbon atoms are connected by a double covalent bond. So they're sharing 2 pairs of electrons. They're unsaturated, we call them, because they don't contain the maximum number of hydrogens possible. Okay, the generic formula, look, it's the same as the cycloalkanes. Okay, so we have to be a little careful. We need a little more information if we give you a generic formula on those, but we're not going to get into that too depth, so don't worry about it. So here's an example, ethene. Please note that they enes are going to end in ene. Ethene, 2 carbons, there's our double bond. Since we have 2 carbons, it's 2n for hydrogen, so 2 times 2 is 4. 1, 2, 3, 4. There's an example of an ethene. Okay, so alkanes, cycloalkanes, and alkenes. Alkynes, okay, is the third type. What we're going to see is there's 2 carbon atoms that are connected by a triple bond. Okay, alkenes are double, alkanes are single, alkynes have a triple bond. Once again, like alkenes, they're unsaturated. Here's our generic formula. Okay, Cn, 2n minus 2. Why we get minus 2? Because we're having another bond put in. So example of this, ethene. I should see by now, F prefix means 2 carbons. Here's 2 carbons. Well, 2 times n, it's 2 times 2 is 4, minus 2 is 2. So 2 hydrogens right there, which looks something like this. Okay, so 3 basic types: alkanes, alkynes, and alkenes. We also have the cycloalkanes. I know it's a lot of naming. Okay, all you're really going to be responsible for is knowing that alkanes have a single bond, alkenes double, alkynes triple bonds, and cycloalkanes are in a circle. Okay, to name these, what you're going to do is you're going to find the name of the largest continuous carbon chain, meaning count how many carbons there are. And for us, we're just going to do straight chains, meaning the carbons are all going to be connected. Okay, and then you're going to use a prefix for the beginning of the name, which the prefix corresponds to how many carbons there are. Okay, you need to memorize these. Okay, so 1 is meth, 2, as we've seen, is eth, 3 is prop, like propane you use in your grill. Okay, butane, if you have a butane lighter, it has a 4 carbon chain. Pentane, hexane for 6, heptane for 7, octane. You have an 85, 87, 89, 92 octane rating in your gas. Well, that's talking about a type of alkane. Okay, 87 is something different. Okay, 9 is non, and then 10 is dex. So let's pause this, copy these down. You're going to need these. And then what we do is we put the ending of ane. We're only going to worry about naming alkanes. You're not going to worry about alkenes or alkynes. You're just going to be able to name the alkanes. So on the test, you're going to be responsible for being able to name alkane hydrocarbons only, not the alkenes or alkynes. So just focus on the alkanes. Alkenes and alkynes, you'll need to know how they're different from an alkane with the double and triple bonds, and same with cycloalkanes, but we're not going to have you name them. So let's do an example. Methane. Okay, our prefix meth meant 1 carbon. So we put our carbon, and we know carbon has 4 bonds, so we put our bonds out there, and they filled up with hydrogen. Okay, so the other way we can write it is a carbon with just the lines out. If there's nothing at the end of these lines, we assume it's bonded to a hydrogen. It's just kind of a shortcut, a lazy way of writing it. Ethane, we've already done this. We know F means 2, so there's 2 carbons bonded with a single bond, and then carbon still has 3 more, so we put 1, 2, 3, so there's our other hydrogens on there. So ethane, 2 carbons, and then 6 hydrogens on there. Remember, it's C, H, 2, H is 2N plus 2. Okay, that's our formula. You should know that formula. How about propane? Okay, propane, pro means 3, so 3 carbons, they're bonded together, and then this one is at the end, so it has 3 carbons, 3 bonds, filled with hydrogen. This has 2 of its bonds going to carbon, so the other 2 go to hydrogen, and this one's at the end, it has 1 to carbon, so 3 others for hydrogen. Butane, like a butane lighter, as I said. Butane means, bu means 4. Okay, but means 4, so here's our 4 carbons, and the hydrogens coming out of those. It's really important that you put these bonds coming out, and you should, for our purpose, why don't we go ahead and write the hydrogens on there so we're not being lazy. Okay, so that is just a quick introduction to organic chemistry. Honestly, the only thing that you're going to be really held responsible for is being able to name the alkanes, which you need to know the 10 prefixes for them. Okay, we should be getting a lot of prefixes, so don't get them confused with the ones for covalent bonds. Some of them are similar, but they're also different as well. Okay, remember, alkanes always end in ane, so the prefix plus ane on there. Then you should also know the difference between alkanes, alkynes, and alkenes, and cycloalkanes. That how many bonds they have, and that the cycloalkanes form a ring structure. Okay, guys, this wraps up our unit on bonding. There's a lot to know. Okay, you need to get this down so that you're able to look at a compound. Tell me, is it ionic? Is it covalent? Okay, if it's covalent, is it just a binary covalent, or is it an organic? Okay, how do we know if it's an organic? It's going to start with carbon. It's going to be a carbon hydrogen on there for us. Alright, guys, if you're getting lost, as always, please come see me, and I will talk to you in class to go over this organic in a little more detail. Take care, guys. Bye.